All right, in our last class, we ran a little kind of out of time, and I know we didn't quite get this inverse operation idea down, so I just wanted to touch on it a little bit in this video and have you try a few questions on your own before next class, okay? So to try to explain this, I'm going to start by, I'm not going to throw any variables or anything like that in there. I'm just going to go through and try to explain this with numbers. Okay, now let's say I take a random number like 5. Okay, now if I take 5 and I'm going to add another number to it. Let's say I'm going to add 6 to that. Well, if I take 5 and I add 6, now let's say I wanted to get back to 5. Okay? Well, if I added 6 to 5, but then I wanted to go back to 5, what I would have to do is end up taking away 6. If I added 6 and then took away 6, that's just going to give me 5, right? Same thing, let's say it was, I did with the multiplication. Let's say I did 5 times 6, okay? But I wanted to go back to 5. Well, 5 times 6 is 30. So if I wanted to get back to 5, I would have to divide by 6, because that would end up being 30 divided by 6, which is also equal to 5. Now this works with, let's change the order. Let's say, I'll change the numbers. Let's say I did 10 minus 3, okay, which would give me 7. But if I wanted to get back to 10, I would add 3. 10 minus 3 plus 3 is equal to 10. Hopefully you're looking at this and it isn't like totally like blowing your mind. Like, let's say I started at 10 and I divided by 2. Well, what would I have to do to get back to 10? I would have, because 10 divided by 2 is 5, I would then have to multiply by 2, which would take me back to 10. These are all examples of inverse operations. Like if you look, I'll just highlight these. The plus 6 minus 6 times 6 divided by 6 minus 3 plus 3 divided by 2 times 2. They're all inverse operations. And what inverse operations do, okay, is they kind of just undo each other. Like if you do them consecutively with the same number, it's like you really didn't do anything at all. And so that's what an inverse operation is. It's something that undoes a number, or it essentially makes it equal to 0, okay, because it's not changing that initial starting number. So if I had, let's say, I'll give another example here, 12 plus 8. And I'm going to say that is equal, well, we know that 12 plus 8 is equal to 20, right? Now, that's a true statement. Let's say I was to go through and take away 8 on this side. Okay? Well, we know that plus 8 minus 8 is equal to 0. Now, if I did that, this would no longer be a true statement, right? It would, if I just did minus 8 on the left side of the equal sign there, that it would be 12 equals 20, which is not true. Well, if I wanted to make that still be a true statement, not only do I have to take away 8 on the left side, but I would have to take away 8 on the right side. Now that's a true statement. Like if I was actually to go through and simplify all that, I would end up with, now it would be 12 equals 12, yeah? So when I write this in algebra, though, usually I'm not going to write it like horizontally like I did right there with the minus 8. I'm going to write it like this. If I have a statement like 12 plus 8 is equal to 20, if I want to take 8 away from both sides, what I'm going to do is I'm going to just put it underneath. So I'm going to put a minus 8 right there, which cancels those out. But if I do that on the left side, I got to do the same thing on the right side. So that's, and again, that's going to leave us with 12 is equal to 12. Okay, so in math, a lot of times what we want to do is we want to try to work vertically as much as possible, like working up and down your paper as opposed to horizontally. And that becomes important once we get into our more complicated problems. Okay, so now that we've kind of talked about that a little bit without variables, let's just throw in a few problems that do have variables. So x plus 8 equals 20. So take a moment. What's the answer to that? All right. If you said x is equal to 12, you got it right. Okay, good job. You solved your equation. So that's the whole point of doing these inverse operations, is to solve the equation. But we go through and we use the inverse operations, so we get a systematic way of solving these so that it's easier, or we have something to use when the problems get more complicated. So for this problem, if I'm going to try to isolate the x, okay, so I want to get that x by itself. You know, like on the previous slide, let me go back one. Okay, when I started with a number like 5, And then if I said, okay, if I add 6 to that, well, then I have to take away 6 if I want to get back to where I started. Well, that's really what I'm going to do right here. You see, I've got a number and I'm adding 8 to it. Well, what I want is I want to just be left, I want to get back to just x. So what I need to do is then I need to take away 8. And again, I'm working vertically here instead of horizontally. So if I do plus 8 minus 8, those just go away with each other, and all I'm left with is x, which is what I want. I want to be left with 1x. And I could put the 1 there. In algebra, we don't usually write the 1, so I'm going to take that away, but that's what I have. I've got 1x. But remember, if I take 8 away from the left side, okay, that is no longer a true statement. And let me go back one more slide. So it's just kind of like what we did down here at the bottom. When I took 8 away from the left side, okay, well, in order to make that statement stay an equality, to keep the left and the right sides equal, I had to take 8 away from both sides. So that's what I'm going to have to do right here. Take 8 away from both sides. And then once you do that, you're left with, okay, not just the x on the side. I could write plus 0 if I wanted to, because that's what 8 minus 8 is going to be. But x plus 0 is just x. So I'm not even going to include that 0 there. But on the right side, I get 20 minus 8, which is 12. So the inverse operations that you're showing here is the minus 8 and minus 8 on both sides. All right, let's try another one. Okay, take a second. What's the answer to that problem? All right, if you said x is equal to 4, you are correct. Maybe a little bit trickier because I got some negative numbers and things like that thrown in. But if I go through and look and see, okay, what are my inverse operations in this problem? Well, I'm starting with x, and you see I'm taking away 6. So if I take away 6 and I want to get back to just x, I need to do the inverse operation of minus 6, which is plus 6. Minus 6 plus 6 is 0. Those just cancel each other out. But if I add 6 onto the left side in order to keep this a true statement, I've got to add 6 onto the right side. And once I do that, then you are left with x, 1x over here, and a positive 4 over there. Negative 2 plus 6, which is equal to a positive 4. Again, my inverse operation is adding 6 onto both sides. 2 more. Take a look at that. What's my answer? All right, if you solve this and you got an answer of x equals negative 6, remembering that a negative times a negative is a positive, you are correct. And on this question, don't be confused just because you see a minus or a negative sign right here. What I'm doing is I'm doing negative 2 times x. And so when you're multiplying a number, like if you have a number x and you multiply it by negative 2, in order to undo that, you have to do the opposite. You have to divide by negative 2. So that's what I'm going to do right here, is I'm going to go through and I'm going to, let me show you, actually, this might be a little bit easier to understand. This isn't how we normally write it, but I could write this problem like x times negative 2 is equal to 12. Now, to undo that, what I would be doing is I would then have to divide by negative 2. Okay? And I would have to divide this side by negative 2. Okay? Let's go back a couple of slides. Okay? It's kind of like this problem right here, okay, where we started with 5, and I'm multiplying it by a number, and then I have to divide it by the same number to get back to where I started. So let's go here. I'm on this problem, what I'm going to have to do is divide both sides by negative 2. But I don't want to work horizontally like this. I want to work vertically. So I'm just going to use my fraction line to show division. So I'm going to divide both sides by negative 2. What is negative 2 divided by negative 2? Well, it's just 1. Okay, so when I do this, those cancel each other out, and you're left with 1x. And again, you can leave the 1 there if you want. You don't need to. But we're left with 1x, and on the right side, 12 divided by negative 2 is negative 6. Same thing that you got mentally, probably. All right, let's do one more. So on this one, it's x divided by 7 equals 8. And again, I could write it like this. I could write x divided by 7 equals 8. And if I wanted to undo that division, what I would have to do is the inverse of it, which is multiply by 7. Whatever I do on one side, I've got to do on the other. But I don't want to work horizontally like this. On this one, I guess I kind of am going to. How you would organize this, because usually you're going to have the division line written as a fraction line. I'm just going to write it like multiplying both sides by 7 in this way. Because what happens when you divide by 7 and multiply by 7, they just undo each other. They cancel each other out. So that's what happens right here, is those get canceled out. And then you're left with 1x. So I'm left with 1x is equal to 56. Oh, I should have stopped for a moment and asked you for that answer, but that's okay. So that's a little bit about inverse operations. So what I would like you to try to do is those up at the top, those are the 4 problems we just did. In your math journals, I would like you to go through, and those 6 problems on the bottom, 1 through 6, I'd like you just to write it down in your math journal, solve it using and showing your inverse operations. So your work really should look a lot like these examples up here, but you're going to be solving those problems down there. So go ahead, do those in your math journal, and then you are going to scan that and upload it into Google Classroom. And don't worry about checking it. We'll go ahead and take a look at that in class.